Okay, let's get going here. And for tonight's entertainment, we have Meetup going to talk about everything to do with small things, internet devices, IoT and Arduinos, uh, other kinds of things. And he wrote the program called Visuino, which some of you may already have used in your working with those small devices. So without further ado, take it away, Boyan.
Well, hello everyone, and thank you for the introduction, Jim. I hope I will not disappoint you. As you already know, my name is Boyan, and I, among other things, created Visuino. Since it's a Delphi crowd predominantly, you probably know that I have been doing Delphi for quite some years, and have done a number of Delphi libraries, which are available on the Meetup website. And a few years ago, about 5 or 6 years ago, I was very stressed with some work that I was doing, well, more or less on contract basis. That was a more complex arrangement. And the people I was dealing with were not very pleasant people, to say the least. So my nerves were not in in their best possible condition. So to distress myself, I decided to buy myself Arduino kit. This is probably, well, it's a display connected. But this board here underneath those shields is, if I remember correctly, the board that I bought with this kit. It was Arduino Mega. And then I discovered that Arduinos are very difficult. They're very easy to connect sensors and stuff to them and motors and things, but they're quite difficult to program even for experienced developer like myself. So that's how I ended up developing Visuino. I developed it for myself. At that time, I had already developed for many years OpenWire, and I had my OpenWire based libraries, and I had even OpenWire Studio in some beta form. So I decided to take all that one step further and develop Visuino. So let's start with screen sharing. So you should be able to see the screen now.
Yes.
And why we'll be using Arduinos, just quickly. Well, Arduinos are very affordable. You can get them for like a couple of bucks. After this screen share, I will show you on the screen how small and how cheap they can be. They're quite resilient in general. I have not burned yet Arduino. I have damaged some other equipment, but never Arduino. There are a lot of clones. Yeah, we'll cover that briefly. Arduino initially came as a board, and let me switch again, stop the screen share, and I'll show you. This is a small Arduino Nano, and this is among my favorites. This guy you can get for as cheap as around $2 on eBay. So sometimes I buy them as a pack of gums, right? I have never burned one of them, but if I burn $2 equipment, I probably would not cry my eyes out, right? I mean, it's pretty affordable. And it's not super powerful, but being that cheap and resilient, I mean, I'm happy with it. And this is what Arduino is in terms of hardware. In terms of software, Arduino is a development environment. And before we go to the software, let's return to the screen share. So there are a lot of clones, including Teensy, Edison, Galileo, Curie, Femto.io, and so on and so forth. Basically, those are boards that are made to be compatible with the Arduino API. When the Arduino people developed the Arduino board, they also came up with fairly standardized API to work with pins and things like I/O and serial ports and things like that. And they created a simple IDE, which I will show you right now. This is the Arduino IDE. And traditionally, you would work with it doing something like this. You say serial oops, begin 9600, which is the speed of the serial, and then you'll say something like serial print line. Of course, if I learn how to spell. Something like this, right? And if you want to set a certain port to high or low, you will do things like let's say port 13, and you say I want to say to high. Yeah, okay. And you continue coding like this, which is laborious to say the least, and error prone. Not to mention that if you want some delay, well, you can say delay 1000 between high and low. But if you want to control some other ports or anything else, well, tough luck. You're just sleeping here. You basically have a sleep here. So that's not very practical if you want to control multiple ports and do multiple things at the same time. Let's finish with Arduino IDE. Because Arduino IDE, when they developed it, they made it pluggable. They allow you to install other boards. And again, if I return to the IDE, I can come here to tools and see a long list of boards that I have installed that are supported by Arduino. And you can see that the list goes on and on and on and on. And I can install more boards. You can go to boards manager, and after a bit of a wait, it's inquiring boards, and it's still updating. It's opening a list of boards that I can install. Some of them I have already installed, others I have not. And you can add even more, come on. You can add even more repositories by adding here board manager URLs. You can add more URLs where it can go and query for additional boards. So you can install thousands of different devices that you can compile for. That's good. As I said, I mean, the Arduino IDE has its advantages. The disadvantage is that it is cumbersome to program. But since it was made a pluggable platform, there is a vast number of other controllers that are now supported by it, including even the Raspberry Pi. So here is an example of a variety of microcontrollers that are supported. Let's go to what are the Arduino challenges. We already covered it. One of the disadvantages of Arduino is that even if you want to collect data, there is typically only one serial channel, and we'll play with that very shortly. If you want to monitor multiple channels of data, then there are no tools for that. And us being Delphi developers, for us it's even tougher because, I mean, if we want to integrate our Delphi or C++ builder application with our Arduino project, there is not much we can do with the normal Arduino. I mean, we can pass the serial port, but that's the best we can do. So then comes Visuino, and I'm going to skip this. So how it works, you do your Visuino project graphically, click a button, it generates the Arduino code, and from there you can use the Arduino IDE to compile using the appropriate board and upload to whatever you want. And without further ado, we can go ahead with our first project. So this is Visuino. Here we have a graphical editing area. All this will look familiar if you come from Delphi. On the left, we have properties or object inspector, as we usually call it in Delphi. And we have this navigation area here, which allows us to easily navigate. Here we have our components organized in categories and subcategories, whenever subcategories are appropriate. And there is a vast number of components that I have developed. Some components will appear in multiple categories because they have multiple I mean, they're applicable in multiple categories. Right? So let's start with the first and simplest possible project. In Visuino, usually you start with something like blinking LED. And for this, we can add a pulse generator. As you can see, the pulse generator appears under generators digital category. It also appears as digital component and under digital sources. We'll pick it, doesn't matter from where, and we'll drop it in the design area. Here in the center, this component is always present, and it represents our Arduino board. And at the moment, I have selected Arduino Uno, but I can change it to something else. As example, Arduino Nano, which is almost identical to Uno, except actually the Nano, being smaller, has more pins, oddly enough. So selecting a board happens by clicking on this button or double clicking on the component. And here we have list of boards by categories and subcategories. We can expand the list. And again, a board can appear in multiple categories because they're based on processor as well as manufacturer. So you can drill down by manufacturer or by the base processor. Now, when you select your board, I have done pin mapping, and it shows you the capabilities of each pin. So this pin, as example, obviously can work as input or output, and it also has LED unit, which I have labeled. So pin 13 has LED. If I connect my pulse generator to a digital pin 13, I can control that LED. And if I click on this button now, our project is ready. So while the ID is opening, I'll connect my USB port. And let's switch to camera view so I can show you what I'm doing. Okay, so this is the board. I'm just connecting it with the USB cable. Just use this extender. Hopefully it should be long enough to show you what's happening. And again, I'm sorry, this is the first time I'm doing this type of event, so I am improvising as we speak. I will connect it to the USB port. It's probably running some code at the moment. And now I will switch again to screen share, temporary. And I will select my board. In this case, this is Arduino Nano. I presume I'm showing the right screen, correct?
Yes.
Okay. And I'm going to select the port. Doesn't matter, it lies. This is not the correct type of board, just the driver is different. That doesn't matter. And now I'll click on this button here. And there are two buttons. Basically, the Arduino IDE is super simple. It literally has 2-3 buttons for all practical purposes. So there is like open and save project. There is a new project. There is compile, and this one compiles and uploads. So we'll just click compile and upload. And it's compiling the code. It's going to take a bit. And now it's uploading the code. And the code is uploaded. And if we switch back to camera view, you can see that this LED here is blinking. Do you see it?
Yep.
Okay, so we have our first project. Now let's start with a more interesting stuff. Obviously, this is a very boring and stupid project. So let's start with serial communication. So let's assume that we want to read one of the analog ports and we want to receive it over the serial port. So again, in this case, I just connected the analog output pin to the serial pin. So all of these guys here, I'm calling them channels. However, they're hardware pins on the Arduino. And since a hardware pin receives data from the outside world or some sensor or something, and that data arrives as hardware data, then gets converted into software information or piece of data, and gets output through this pin as a software output and comes into the serial where again it goes onto the computer. So this is the project. Let's upload it. I'll upload. Okay. And if I open a serial monitor, you can see that the data is arriving. And if I start touching the board, you'll see, and I'll show you that actually even a better way. So right here, I have a built-in serial monitor with a scope. So if I connect, you'll see the data arriving and being displayed on the scope. And right at the moment, I'm just touching the board to cause a bit of noise. And it may, yeah.
So are you just touching the analog input?
I am
or
reading.
is what are you sensing? Is it a temperature sensor?
Right at the moment, I'm sensing, and I'll show you again. I'm sensing analog input 0. You see that?
Uh-huh.
And again, as soon as I touch it, I'm going to introduce some noise because I don't have a physical sensor. And yeah, it has some capacitance, so it's dropping now from the capacitance when I release pin. If I had a real sensor there, it would have been more meaningful. And if I try to put a little antenna, we may be able to even pick the 50 Hertz. So analog 0 should be this guy here. Well, this should, no, it's not 50 Hertz, but it's picking some frequency. So I just touch a wire right at the moment and it's just picking some frequency. Or it could be a 50 Hertz frequency, who knows. So in any case, this is how simple it is to work with sensors. And since we're on this, let's quickly switch to Delphi. I'll have to disconnect, of course, from the port. And let's read this data from Delphi. So here I have, for the people, and since this thing is going to be also for folks that have not heard of Delphi, Visuino itself is written in Delphi. And I will talk a little bit why I wrote it in Delphi. But before we do that, I will just quickly show how we can read the same data in Delphi. So here I have installed my suite of components, which include Communication Lab. And I have COM port component. I can select which port. And I can just drop a terminal and switch to the OpenWire view, connect my COM port to the terminal. Yeah, it's going to ask me to save it into some folder because I have how to save. Run the project. Come on. Yeah, okay. Run the project.
You might explain what the OpenWire project is.
Yeah, I will. I will.
Okay.
Let's quickly first see the result of our effort. I hope it's going to come on the right monitor. No, it did come on the wrong monitor, naturally. So I'm going to move it here. And you can see the same data. Let's introduce a bit of noise again. You can see the data changing as I'm touching. So let's start with, first of all, what's Delphi for people. And I'm sorry, most of the people here probably are Delphi people, but this recording is going to be for the general crowd. So just a brief overview. Delphi is a very advanced and user-friendly development environment that traditionally was for Windows development, but nowadays has expanded to allow to develop for Mac, iOS, Android, and Linux. And Embarcadero, the company that currently develops the product and sells the product, is working to expand it to other platforms. Well, that's one of the many reasons I selected Delphi as a development environment for Visuino, was that, first of all, I can target multiple platforms. And at the moment, Visuino is Windows only, but I am working on other versions. Second of all, the Delphi language, which traditionally was called Object Pascal, but now is just referred to as Delphi language since it bears very few resemblances of Object Pascal. And the Delphi language is a very modern language. It supports advanced features such as quite advanced RTTI and attribute-based programming, which was critical for the Visuino development, functional programming, anonymous methods, and many, many, many other very modern features. For me, the critical requirements to develop something like Visuino were, number one, it had to compile pretty much native code to gain maximum performance, and also to be able to work with hardware doing communications and everything else. Number two, it had to be as cross-platform as possible, at least to allow me the path of making Visuino cross-platform. Number three, it had to support declarative programming, in my case, through attributes. Specifically, attribute-based programming was critical because the entire Visuino concept of component-based development and code generation model is based on attributes. And to keep everybody entertained, especially the people that like code more, I will briefly show you what I mean. So this is what I'm working on right at the moment. And you can see that this particular component, well, this is actually a module, but the components are the same. There is no code. There is not a single function. Everything is declarative based, and everything is based on variety of attributes that guide Visuino of how it will generate code. So this type of programming, that from a practical standpoint today, as far as I know, is available only in Delphi and .NET. And .NET being not that much cross-platform centric and not quite native in terms of code generation, was obviously not the right choice for me. So I had no choice practically, but use Delphi for development. And again, since we're on this page, and since I have planned to show some component development briefly. So this is a component that is included in the component SDK for developing your own Visuino components, because Visuino is expandable. You can develop the same way as you can develop components for Delphi. You can develop Visuino components. Here is how you can develop your own personal Visuino component. First of all, you typically inherit from one of the base classes, in this case, analog flexible filter class. You name your class. You specify include file where the C++ code for this component is going to be implemented. You specify the category or multiple categories where the component will appear on the toolbar. You specify the name of the C++ class which will implement the component. Here you specify the name which will be used when the component is dropped inside Visuino. So here, if I drop this post generator will come as post generator followed by index number. And then you give it a user-friendly name, which in this case is the name as it will appear in the toolbar category. You specify that it will be in the free version of Visuino, because Visuino comes in 3 flavors. There is a completely free version, there is a low-cost standard version, and there is a high-cost professional version used by in the industry. So then you declare some fields where your properties will be. In this case, this matches like these properties that will appear here. You declare your properties in your publish. So this is in the protected section, the fields for the properties. In the publish section, your properties, there is no setter getter method. They're just directly mapped into the fields. And you add the attributes of the properties. I will not go into great details about those attributes. There will be more videos and stuff like that on those. But this example sets the default value for a floating point property. This specifies the way the code is going to be generated. And this specifies a limited range for your property. So this property cannot go lower than this, and it cannot go higher than this. And then you can have a desired design range, which is the recommended range. And design range is used if you expand this face. So this face, as example, has a range, which you can use in design time. So this is the design range, goes into the slider. And this is the absolute value range. So that's your entire component in terms of Delphi. And briefly, I will show you, and this explains how I develop all the components and stuff like that. So let me quickly open Visual Studio 2013. So this is the corresponding C++ file. I usually, just because I have it handy, I use just Visual C++. So you can see here, that it's just a quadratic function class. It has enable property, output pin, A, B, C properties, their templates, and then the class inherits from all of them. So it's a multiple inheritance. Here I'm declaring a pin property, which is the output pin, and then I have enabled A, B, and C. And here I have function that will be called whenever data arrives on input pin. If the component is enabled, I'm going to do some calculation and send output to the output pin. If the component is disabled, whatever comes on the input pin will be sent to the output pin. So that's everything. Okay. I'm sorry, maybe a bit boring, but I just wanted to say that. I also want to mention for the non-Delphi people that there is also a free version of Delphi called Delphi Community Edition, or Starter, I think they also call it. So I greatly encourage you to check out Delphi. It's a really great development environment, especially if you want to be a maker and make a cross-platform applications and apps. So now there was a question about the OpenWire. Delphi traditionally comes with code editing and visual form designer. I have developed the OpenWire technology that plugs into Delphi and allows you to visually connect components. So in Delphi, if you drop components like this, usually you write code to work with those components, and I'll show you how. As example, the data that was arriving, I can come here, go to this property, double click, and here I will have event where I can receive my data, and then I can convert it to string or work with the raw data or anything else. I have created on top of that a plugin because Delphi is expandable IDE, which allows you to graphically connect components the same way as in Visuino. So you can drop my COM port and my terminal, and you can connect them. So let's see, this was very stupid. We're just reading data from one channel. What if we want to read data from multiple channels? For this, I'll just do a sign generator. I will do a triangle. I can even do a pulse generator. Why not? No, well, let's do pulse generator. So we have three different data types, and we'll even connect some unlock pins. So for this, I have introduced a packet component. Packet component. So if I drop this packet component here, I can click here and add some channels to it. And let's add 3 analog channels and 1 digital channel. And I can add all kinds of data. And let's say here we have this guy connected, this guy connected. Here we have this guy connected, and to this analog, we'll just connect one of the analog pins. So you can see that you can mix data. And our pulse generator, we can even connect it to our pin 13. Why not? We can do multiple things, right? I mean, we can control the pin and at the same time send data, right? Okay, I don't need to say this. So now here I'll add a header marker, which is a unique ID, and that allows me to recognize the beginning of packet. And you can just put any random unique ID. So now if I generate the code, so now I'm uploading this code. Okay, code uploaded. And if we go to Delphi, we'll start a new, before we go to Delphi, let's connect to our application. If I go to serial here, I can select packet communication, so I can work with unformatted text. If I connect to unformatted text, I'll just see some garble, which is binary information coming on the serial port. Instead, if I select packet, which is this packet component here, and pick two things will happen. First of all, the scope will be populated with my channels. And second of all, I will immediately have instrumentation panel. And I can customize it, but that's a different story. Well, why don't we customize it? So I come here with elements. I can select in my visualization that this one is a thermometer. And for analog 3, well, analog 3, yeah, okay, analog 3 is good. Analog 3, I will select to be a linear gauge, why not? Okay, so I have 3 different gauges and LED. I customize them in the properties for the packet component. So now if I connect, you'll see that all the signals are coming at the same time. And if I go to my instrumentation panel, the third analog is me touching the Arduino IDE, which is a very small value. So it's not going to scale good on the scope, but you can see that it is actually, I can try to, oh yeah, it actually was coming quite nicely. It's this blue guy. You can see that I have multiple channels and I can monitor them right here, right? So all of those things are coming and being monitored, which is very difficult traditionally to do in the Arduino IDE. And now if I go to Delphi, we can create application which talks to my Arduino over all of those channels. And quite frankly, we can do the other way around, but let's see how the time allows, and it's a bit difficult to zoom. So I'll do unpack it. Here we have to unpack the data that arrives. We need a COM port again. So we have COM port, unpack it, and we can, well, let's start with scope. So I can just do a scope component. Here I can do 3 floating point channels. One Boolean channel. We have to go to properties and set the header marker to be the same, 55, 55. So both sides will talk on the same frequency. Connect the COM port component. Add, well, yeah, okay, why not? Actually, I could have done this and this. And now what we have here is the 4 channels being connected to the scope. I can save that. Make sure the right COM port is selected. I almost forgot. And run the application. Again, it's going to come on the wrong monitor. But in any case, here is our Delphi application now receiving the data from multiple channels. And what if we want to actually access the data in code? There are many, many ways to do that. I'll actually show you one more interesting trick for us as Delphi developers. Let's say we have some label. I actually will do it in a button. Why not? I've never done it in button, but this time I'll do it in a button. Let's say we want the caption of this button to reflect a value that arrives from the packet component. So I can come here and with my OpenWire Visual Live Binding, I can add a sync pin to my caption property. I can come here and connect this. Why don't I use the analog pin and connect right here? And let's see if this works. Let's run it again. I'm sure it's going to come on the wrong monitor again, but that's live when you do live presentations. And Delphi itself moves to a different monitor, but that's okay. Do you see this? The caption of my button reflects the analog value, and I'm touching at the moment, as it comes from the Arduino. So we can do a visual live binding with any of the properties with the data that comes from Arduino, but we can also double click on the component, select a channel. As example, again, I'll use the same channel, go to events, and on value received, I can put a, well, why don't we add a, it's a bit dangerous. I'll just put a breakpoint. Well, okay, we're Delphi. I'll put a breakpoint for now. I'll show you another trick for us as Delphi developers in a second. And it's going to come on the wrong screen again at Delphi, but it stopped on the breakpoint. And if I inspect my analog value here, it will be the analog value that arrived from Arduino. So here we can write code to work with the data that arrives from the Visuino programmed Arduino. And to show you how it actually works, I'll add a memo. And we'll keep adding the data into the memo and go into the code. Sorry, long day here. I will just use Meetup threading synchronization to synchronize with the main thread. Main thread execute self, true for now. And here, synchronizing with the main thread, we'll use anonymous method. And we'll add data to our memo. And there are other ways to synchronize with the main thread since memo is not thread safe, but I just do it this way. And value string, and let's run it. I hope I'm not boring the people that are not that much Delphi-centric. But do you see it, guys? Now we actually receive our data in code and it goes into our memo. And I'm not going to overflow the memo with data. And yeah, that the memo disappeared. I didn't stop the thread, but that's beyond the scope of this, how you develop thread safe code. So this is on the Delphi side. Let's see, we're progressing quite some on the time. Let's do a little IoT maybe.
Sounds good.
See what, yeah, let me see what we can use quickly from the boards that I have around. So how about we do some robot? So in this case, this is Arduino-based robot. Arduino is the board here, and on top of the board is installed Shield. Shields are boards that you can plug on top of the Arduino, like this. Right, okay. Sorry, the camera is here. So this is the Arduino board here, and this is the Shield. and they stack on top of each other, just like this. I hope everybody can see well. So this robot has Bluetooth module. The Bluetooth module, unfortunately, is on the same serial port, which we need for programming. So the first step to program the robot is to remove the module. I wanted to do some self-navigating robots, but the time will not permit us. Start screen sharing. Start new Visuino project. In this case, we'll add Shield. And this is a Lego robot version 3 Shield. I happen to know that this is version 3 Lego, but it's not that difficult to know what version your robot is. The next thing we'll do is we'll try to control it from mobile phone. So for this, we'll use a remote XY app. I was thinking maybe we can write some Delphi apps, but I don't think the time will allow me, even with my tools. The next thing we will do, and I'll give you a quick introduction to Remote XY, and I greatly recommend it to anyone. Let's go to the Remote XY website. So this is Remote XY. It's an app, and there is an online GUI editor for the app. So here I can start with the editor. So this is an editor. I'll add a joystick. And since we want to have some fun, let's add this slider, make it horizontal. It should work if I remember correctly. Oh, and why not? Let's make it even more fun. Let's add even a scope. So let's do a two-way communication. So yeah, let's make the application the app as complex as we can within a few seconds. So center, but I want it automatically center, and just center bottom right. Okay, that looks good. I like it. Make this guy bigger, position this guy here. So we have a joystick, we have scope, and we have a slider. So we have our design. Traditionally, you can click here, and it's going to generate some Arduino code for you. But we will not really use this Arduino code because you have to write the rest of the code, right? So you have to write off your Arduino code here. Instead, in Visuino, we'll drop remote XY component. We'll select parse remote XY Arduino code, paste our code that we copied from the website here, like this. Click OK, and we're automatically configured to work with this project. So the next thing we do is we need a communication protocol. Remote XY can work over TCP with a local server running on the Arduino or similar type of controller. It can work with the cloud. You can create a cloud account and control Arduino devices over the internet, or it can go over serial port, and our Bluetooth module is a Bluetooth to serial module, so we'll select serial. We'll connect the serial port to our Arduino. And now we need to control our motors. First of all, here on the scope, I'll connect our ultrasonic ranger. Where is the ultrasonic ranger? Right here. So I can measure distance and display it over the scope. The servo of the ultrasonic ranger will be connected to our slider, so we can control the servo with the slider. We need to convert left and right, forward, backward into direction and speed, basically, into left and right speeds for the two motors. So we need steering differential components, so we convert to differential driving from direction and speed. And our project is ready. Now I can open the Arduino IDE. I'll connect the robot to the USB. I'm going to switch to camera view. I presume you can see me now, right? So I'm connecting
Yes.
the USB, connecting the USB to the computer. In the Arduino IDE, again, I'm going to switch to screen share. In the Arduino IDE, I need to select Arduino Uno with this board. And I need to select the COM port. In this case, it shows it correctly. Click on this button. It will compile and upload the code. I did one little mistake. Okay, let's correct that mistake because I don't like what the Arduino is doing. For my elements, for the slider, I'll put initial value of 0.5. That will center the servo. That's the only change I want to do to this project. So let's open it again. Yeah, otherwise the servo moves to one side and I don't like that. So I prefer the servo to be centered.
Oh, you don't like driving in circles?
No, it's not going to drive in circle. It simply will rotate the servo and start pushing it, and you can theoretically even burn the servo. So I just don't like that. Overloads the servo a little too much. So I like, well, I mean, the slide, it's not fault of the slider. The slider simply didn't know that I'm going to use it for a servo. So, wrong port, yeah, okay. Yeah, other than that, we are right on the money, I believe. So I promise that I'm going to show IoT and I'm going to show robots. So we're doing both at the same time. I'm cheating. So here it is. The robot is now programmed and the servo is centered. So we'll start the robot. I'll start my tablet. And let's open, this is the remote XY app right here. It's installed already. Come on. Okay. So it started. I actually have it added, but oh, I forgot something. Before we do anything else, I need to put back my Bluetooth module. So turn off the robot. Install the Bluetooth module, because without Bluetooth, we're not going to be able to talk to this robot. Power it up. So if I, oops. If I click on this plus button and select Bluetooth, Bluetooth is on. That's strange. It should have been able to, Bluetooth LE, sorry, it's a Bluetooth LE module. So it lists the Bluetooth modules. I hope you can see it. I'll select the right module. And here is my user interface. And if I rotate the robot, you'll see that the distance that is being displayed on the scope will change depending in which direction I'm pointing it. Can you see it, guys?
Yes.
And I'll try to both hold the robot. Well, let's see what we can do. So this is the robot. Crap. Okay. This is the robot, and this is my user interface. And I'm going to start driving the robot around while looking at the camera. That's going to be quite some fun. But you can see that I have control over my robot. And with my slider, I can, oops, I overturned the servo, unfortunately. I think I overwhelmed the servo, so sorry, the slider is not going to work. But I can drive the robot. Yeah, I'll have to find the slider. I think I overturned it in one direction a little too much, and now it's locked there. So anyway, this is how you can build your own IoT controlled over Bluetooth robot. The simplest way you can do that with Visuino. Let's turn off the robot, and I'll have some fun figuring out the servo a bit later. Probably I can just, anyway. In the worst case, I have a bunch of servos, so I can replace it. Now, I'll do a quick stop now. You can ask some questions, and then we can do some more stuff if you guys want to do. It's not exactly the way I planned the event, but hey, I mean, it's an improvised event. So any questions at this point?
Well, I'm pretty impressed. I'm a little bit confused on a couple of things.
Sure.
Several different parts, like the Arduino development environment, Delphi, Visuino, and is Delphi just used to develop Visuino? Is Visuino a standalone, or is it Visuino like components that run under Delphi?
Well, Visuino is standalone development environment that was developed in Delphi. That's the short story.
Okay, so when you were doing Delphi, that was how to develop more components and...
Well, you can go into Delphi, and since Visuino was developed in Delphi, you can, and since it uses packages the same way as Delphi uses packages, you can develop your own components for Visuino and install them inside your Visuino. Once when you compile the package, you simply copy it in one directory under Visuino, and the component immediately appears on the tool palette.
Okay, I'm really impressed. I played with the Visuino a few years ago, but I didn't get very far. But I'm really impressed, and I'll try it again.
Well, thank you. I mean, it has evolved a lot. I mean, initially, the very early versions, they were not extremely well optimized. They were developed specifically to be easy to use, right? That has changed a lot. Nowadays, Visuino generates extremely highly optimized code that is so highly optimized that I am having challenge whenever I spend a lot of time to write better optimized code than the one that is generated. And it takes a lot of time and effort to do that. And I'll show you just to see that, to show you that I'm not bullshitting. Normally, if you declare a class, that class, and if you put any data inside that class, how much memory that class is going to take? Can somebody say?
Jim ought to know.
Pardon me?
Jim ought to know.
Are we talking about Delphi, or are we talking about in Arduino language?
In C++, let's say.
Usually there's a pointer for the table for it, at least.
Well, assuming that it's not even virtual. Let's assume this is not a virtual class, so there is no pointer for the table. And you have just a Boolean value in it. How much memory is going to take this class?
There's no virtualization to it. It should take a Boolean. It should take a byte or something.
A byte, correct. Well, in Visuino, the type of class, assuming the Boolean is actually variable, will take a single bit.
So your bit fields mapping
yes.
there.
And you can see that right here. So here is a special class that defines bit fields. Here I have created, here I have created accessors for that class. And further down, you can see that I am accessing those different bit fields. Somebody don't have his microphone.
We got it.
I took care of it.
Oh, okay, sorry. You can see that those bit fields are used inside. Let's see where I used. Oh, right here. The sending here. It's not this floating point, field floating point. Let's see one of the bit fields. So this is variable 2. And we can, oh, right here I'm using it. So you can see that I'm using this bit field for this state variable. So right here, this particular class uses 2 bytes. Not 2 bytes, 2 bits. 2 bits. And it will share the byte with other classes. Of course, eventually everything is going to be aligned to a single byte, but that's how it works. And furthermore, any component, normally a component will have always some member variables. Here, components have member variables only if they need them. If they don't need them, they are replaced by constants. I'm doing that through templates. So a class can have anywhere from 0 bytes to a large number of bytes if everything else, if everything within this class needs to be variable, being variable. So this component, as example, this thing here can be sometimes variable depending on what the class being used for. It can be a constant, or it can be a variable. At the moment, it is being made a constant. If it was a variable, it would be something like this, right? So I can plug in a variety of type of variables or constants depending on what is needed. So I can highly optimize the generated code. So this is how highly optimized Visuino is nowadays. And you can see this IoT project uses 293 bytes altogether. Of
That's
which
amazing.
200 and something are coming from the Arduino library itself for the serial port. So it just uses relatively few bytes altogether. And the code is equally highly optimized. So I mean, you can see that I did a remote controlled robot, fully functional, using almost nothing.
Have you done work with 2811 controllers for RGB LEDs?
Yes. You want to do something? Okay, let's do some. Let's let me
Basically
see.
Christmas lights.
Yeah. Okay, give me a moment.
Give me a moment.
You started it.
That's what I've done most of my work with on Arduino, is controlling building light controllers.
I like how he has some in the background.
Yeah, let's see if this thing is going to work, assuming I can find the right board here in my mess. Where the hell is my groove board?
So did you use anything in Delphi to help you generate the code templates, or did you have to build that yourself?
Which code templates? Specifically the code templates for Visuino, you mean?
Yeah, well, in other words, Visuino generates Arduino code, right?
Correct.
And so did you have to build all custom code generation for that, or did you find any Delphi tools
I,
developed on that?
well, since such code generation doesn't exist in the world, I had to invent this type of code generation, and then I had to implement it. And then I had to re-implement it and reinvent it and re-implement it a few times over the course of 5 years, starting with the very unoptimized initial version,
Right.
all the way to this extremely highly optimized version I have recently developed. And as far as I know, the techniques that I use are all developed by me. Another interesting aspect is that although I love virtual methods, and I am not one of the guys that will keep saying, oh no, virtual methods, they just eat your memory. Virtual methods are not necessarily your friend when you're developing framework like this. There are other approaches that you can use, and I have developed my own approaches for this. So I practically do not use virtual methods whatsoever in the generated code in order to further save memory. So instead of using virtual methods, I use what's called code chain. And again, I mean, this thing is going to get into a much longer conversation, but there is a solution for it.
Okay.
So here they call them new pixels, those RGB things.
Wow.
And in this case, because I'm lazy, I'll just use a groove connector. This is a groove connector. It has both power and the signal. And I use Arduino Nano that has a groove on it. This one is from Seed Studio. So I'll just connect the groove connector. Oops, wrong direction. So the groove connector connects my RGB to the Arduino.
Okay.
And let's see, pick the right connector. This one was USB-C. Where is my USB-C? I had USB-C earlier here. Okay, USB-C connector. So let's switch to code and let's see what we can do. This project, we don't need to say it. So here I will go to M5 stack. Is this no pixels hex? This is, let's select the board. Arduino Nano is this particular board. And I have added to it a groove pin to make it easier. So groove pin. Here we can add a running color. Why don't we add a running color?
That's good enough.
And I forgot how many. Let's see, it has, but let's say 16 maybe or something. And let's say random. So let's say we put a random color. I have not tested this, but who knows? I mean, it may even work. We'll use a clock generator. We'll set the clock generator 5 times a second. Let's say 5 times a second. So we'll clock random color 5 times a second, and this random color is going to go into our running color. And let's clock also the step widget.
Yeah.
Oh no, let's do different. No, I don't like that. Let's try different. Let's add a second clock generator. So let's say this one clocks once a second is fine. And this one clocks, let's say 5 times a second. Okay, let's try it. Let's try it, why not? So connect the board. Where's my expander? Right here. I connected the Arduino. This one is this USB port. Come on, the Arduino IDE is still starting. Okay, so now we have to select, this is Nano, yeah, that's correct. Select the COM port, upload it. Well, this particular did not work well. I'll have to investigate, sorry. This is a development version, so we'll do it different way.
Can you debug use single stepping in breakpoints?
Not in the Arduino IDE. No, when I say the Arduino IDE is super primitive, I mean it. I mean it is super primitive.
The actual code is running on the Arduino controller, so
Correct.
you can only output log messages back to the IDE.
Okay.
Correct. So, it's either port 4, analog 4 or 5. I'm not sure which one it is. So we'll just try both. So running color. Same thing. This guy here. This guy here. And the output pin is connected. And that should be the, oh. Yeah, this module is a new module, and I added it for M5 stack. I have not tested it with the seed window, and obviously my group mapping is not quite right there.
That's okay.
So let's see how it's going to go here. Not to mention that I am running a development version. But it should compile because I actually tested it recently with the normal new pixel libraries. Yeah, okay, that's fine. Let's upload. Yeah, uploading. And let's see. Oh, it worked. Do you see it? It may blind you a little bit. So what I will do in order not to blind you, let's return to the code. Let's lower the brightness a little bit. So go to the component, sharing the right screen, right?
Yes.
Okay, I'll just lower the brightness to 0.0, let's say 3.
That was at 0.1 before, right?
Yeah, we'll make it even less. It's extremely bright. This thing can
But that
literally...
That would be 10%, right?
Roughly, well, it's not linear.
It's
But
not
yes,
linear.
it's...
Well,
yeah.
I know the brightness isn't actually linear, but that's basically if I did put 1 in there, that'd be full brightness.
Correct, correct. If you put 1, it will be a full brightness and it's gonna blind you. Trust me, I have experimented. Those LEDs can be quite bright. We may only have time for a little more fun stuff, but let's see how it all goes. So again, I'm going to upload, and then I'm going to switch to the other screen. I mean, to the camera. Oops, still blinding. Okay, now it should be a little bit better, is it?
Yeah, so it's basically snaking through the lights right now, right?
Yeah. Is it
So hard
better
to-
this way? Can you see the colors?
Yeah, they're washed out, but I can see what it's
Okay,
doing.
I'm just trying not to blind the camera somehow.
And reduce the frequency. So
I
maybe
see it. That's good.
I don't know.
That's good. That's good for me. I see what you're doing with the wire, with how you're using open wire and doing
Yeah,
the diagram of
it works. All I can say is that it actually works, but it's difficult to show it over the camera.
Not without playing with the camera and exposure and stuff like that.
Yeah, exposure and stuff. Yeah, I know. So anyway, any other questions before we try something else?
how many users do you have?
Well, as of right now, there are multiple options. You can run Visuino without registering at all. So I have no way of knowing how many users are there in terms of non-registered users. So there is at the moment a free version. Let's go to the website and look at what are the options. If I spell it correct, it will go to the right website. So there are multiple options. There is a completely free version, and in that version, some of the components will be locked, and you can make projects no bigger than 20 components. You can make bigger projects, but you will not be able to generate code for them. So you can make really complex projects with the free version. It will simply refuse to generate the code if the project is more than 20 components, or if the code contains locked components. But again, you can do plenty of projects with the completely free version. No registration or anything required. Then there is a trial period that you can request, and that's 30 days, which gives you a standard version. And for that, people have to create accounts. So you can go to the login, create account. And there are almost 60,000 accounts being created. So there are almost 60,000 registered users right at the moment on the Visuino website. And then there is also Visuino.eu that was launched last year. And Visuino EU has its own login account. It's handled by another guy who work together. He's doing promotions and sales in Europe. And there is a number of users that have been registered there as well. I have no idea what's the current number of EU users. So we know for sure that there are 60,000 or so users, and probably equal number of users that have not even bothered to register. And then you have the options to buy a standard version, which comes with 4 months of updates. And after those 4 months of updates, you're locked to continue to use with your key the version that was last updated. Newer versions, you have to renew it. You can renew for $39 for a full year. And then there is the option initially when you start it initially to have it both registered and with a full year of updates for $59. And then there is the professional version, and I will show you the difference between the two versions. So this is the professional version. First of all, the standard version does not have code view. The professional version has live code view. So as you put components and things like this, the code view will automatically update, right? And you can see how your code is going to look like. So I can even start changing stuff, and the values here will change to reflect. You can see that this value was changed and matches this value here, right? So that's difference number one. Difference number two, you can actually add subdiagrams. So here I can have a subdiagram, and I can have some analog inputs and outputs or digital, what have you. And I can add components to my subdiagram. So let's say I can add a sign generator here. And then I can go to the main project. And in the main project, I see that suddenly this tab has this component tab has appeared, and I can drop this subdiagram and write it right here. And if I come here and add another pin, it immediately will appear in the main component, right? And I can use it. And whatever I generate or do in this subdiagram will appear here. And I can have multiple instances of that subdiagram. So effectively, you can structure your project into a hierarchical level. And subdiagrams can contain other subdiagrams, right? So that's difference number one. Difference number two, that was technically difference number two. Now difference number three is that we can have also a custom code component, where I can inject my own code in the generated code. So I can include some library. I can add some code to be done in the initialization section. Call some libraries or something. Just some Garbo code. On start, let's say here I can say some really crappy code, doesn't matter. So if I go to the code view, you will see that my include is here. And if we go to the initialization section, which is a little bit right here, in the initialization section, we injected our code, and we injected our code here, and so on and so forth. So I can write my own C++ code that will be injected inside Visuino. And finally, which is quite, well, not really finally. Okay, well, next big one. Okay, let's leave the biggest one for last. The next one is that we have Fourier transformations. So we have fast forward transformation, inverse forward, and inverse complex forward. Inverse complex Fourier transformation. And the forward Fourier transformation can work both with analog data as well as with complex data. So it supports all of those Fourier transformations. But that's not all. The final goodie is that the Pro version comes with full-blown Modbus support, TCP and serial, both ASCII and RTU. So you can do industrial automation SCADA control. I mean, you can both control industrial automation SCADA controllers from Arduino itself, or you can implement your own PLC controller inside Arduino and deploy it in industrial environment and use control software to control your Arduino. And to sweeten the pie, you can go in Delphi, and in Delphi using my control app, you can control such Arduino device. So let's say you can do remote device access, and you can select a, so it's going to be a client, let's say client serial protocol, put some serial port, Modbus client serial port, add some requests. So let's say read some input register. Well, let's say read input registers. Let's say some floating point register. And if we go here, what we can do is hook the Modbus, hook the inputs and outputs of our protocol to the serial, and add some gauge or something where we will display the data. Again, we can program this, but it gets a little bit out of scope and a little bit in the area of industrial environment. And now I can monitor either PLC or an Arduino programmed with Visuino to become a PLC controller. Where is the pro? To control it. So let's say here I can put a device on the server side. I can put a device. I can add holding register, not holding, input register. It was input register table. I can put an input register, which was, well, here I don't have 64-bit, but I can put in 32-bit one. And I can put, again, the same way, I can put serial protocol, hook the device here, hook the protocol to my serial, back and forth. And now I can program this, add some data to monitor, doesn't matter what. And then I can program this thing into Arduino and control it either from industrial automation application of some type, or from Delphi, as I did Delphi application for it. So this is the Visuino Pro, which is the most expensive version, obviously.
I like the TCP from Delphi to Visuino.
Oh yeah, well, I don't know if the time will allow me. Yeah, let's just finish with the
Well,
pricing.
you don't need to show it. I'm just saying that I'm trying to automate Christmas and Halloween decorations, and that's the kind of thing that I need, is to have my Delphi app control Visuino or Arduino type controllers easily. So that's kind of a nice add-on there to make it easy to communicate between the Delphi app and a Arduino controller.
Well, probably the easiest one you can do, there are multiple options. The easiest one you can do is to use one of those, as I showed earlier. Let's switch to camera view. So this module here.
Yeah, the Bluetooth.
The Bluetooth module. This is probably the easiest because all you need to do is just work as a serial communication. So that's really the easiest. In order to do Wi-Fi for Arduino, you have to add some kind of Wi-Fi module, and they're not particularly good options. There is an option to use ESP8266, like Node MCU, which is quite cheap. I mean, this guy is just few bucks as well and comes with Wi-Fi. Or you can use ESP32. I don't have a good ESP32 handy, but I can show you this one. This one is not the best example, but I just happen to have it handy. So this is ESP32 here mounted on a bigger breakout board. This one comes with both Wi-Fi and Bluetooth. And this one usually also costs around a few dollars. So
Okay.
there are versions with ESP32 that are, I mean, also in that price range. I have not been particularly happy, however, with the new Pixel libraries for the ESP32 or the ESP8266. They don't quite have the timing right for some reason. So one option is either you use a Bluetooth module like the one I showed you, or there is another trick that I will quickly show you, and I have even a tutorial for that trick. So, okay, we'll go to pricing a bit later. So let's restart this project, and I'll show you the trick. So the I2C communication, first of all, I'll show you a tutorial for that trick before we go anything else, so you can learn it on your own. If you go to Instructables and go to my boy on M, right? I have I2C communication between two Arduino boards. Should be somewhere here. It was quite a while ago. So the idea is you have two controllers and you have them talk to each other right here. I2C communication between two Arduino boards. So here you have two Arduino boards. They're connected with two wires only and common ground, though you can probably share the power as well. And one of them is reading data and then uses I2C communication to send the data to the other.
I see.
In this case, there are two Arduino boards, but you can do I2C communication between any other boards.
So you're saying to use two boards, one to process the communications and
Correct.
one to execute
Correct.
the actions.
Correct. You can
Okay.
use I2C communication.
That's very clever.
Yeah, thank you. it's often used. So you have two options. You can use I2C communication between them, or alternatively, you can just use COM ports and have one of them talking to the other over the COM port with the packet and unpacket and everything. So you have plenty of options, right? So that would be one way. So use like ESP8266 or ESP32. Try to use the new Pixel library unit. If the new Pixel doesn't behave the way you want it to behave, use it as a master board or slave board or whatever, and then do just use it as a master board and do the new Pixels on the other one.
Yeah, because the boards are so simple in their processing. They're like 1 megahertz or something like that, that they can't do it. Processing TCP or Wi-Fi communications and doing something else is kind of a heavy load, right?
Well, that's not entirely the issue. I can go into more details. The ESP32 is a very capable board. The libraries, unfortunately, the people that have written the new Pixel libraries have not written them very well.
Oh.
And I very often write my own libraries for hardware. 90% of the cases I write my own hardware, but I really don't have the nerves to write new Pixel's library at this point yet.
Okay.
So anyway, let's return to the pricing. The Pro version is similar pricing to the Visuino standard, except it's $199 for the 4-month updates and $299 for the full year. And you can extend for another year for $199. So obviously the professional version is for professionals and for the industry. It's not for hobbyists. This is the version for the hobbyists, the standard version. And for beginners and students and kids that cannot afford better, I mean, I have a completely free version. So I offer the full range of solutions. So next question. Yeah, I spoke probably a little too much.
One question. Where are you, your location?
I'm located in Moorpark, California, which is near Los Angeles. Okay. I was originally born in Bulgaria, but I haven't been living in the States for like 20-something years already, 22, 23, lost. 22, I think. Lost count.
You used to go to the BoardCons, right?
Some of them. I went to some BoardCons and in price, Cool.
Prize cons and whatever they were called
Yeah.
back in
We
the
do
day.
remember the in-price time, don't we?
Oh yeah, I still have a piece of the E when they destroyed it.
Yeah, that was my favorite moment in 2001 when a ape, David I, dressed as ape, came on stage and used a huge bomb to destroy Impress. To
Just
smash
destroy
it
the
into
Enterprise name. Yeah,
Yeah.
that was great.
It was gone for good. Any other questions at this point?
Pretty nice development. It's amazing
you.
how much work you've done.
Oh, thank you. I mean, I really
Amazing.
appreciate it.
beautiful.
Yeah, it's like a work of the lab view. You know,
I would tend to slightly disagree with you, at
Okay.
least in terms of Arduino development. Visuino is what LabVIEW may wish to ever become after many years. LabVIEw
I
is
don't like
nowhere-
LabVIEW anyways. I don't use LabVIEw. I don't like LabVIEw.
Yeah, Visuino is on many levels. It is something new and completely different than anything else. And again, I mean, I have gone through a lot of pains and a lot of trials and errors to try to get it right. And I'm still not 100% sure I have gotten everything right yet.
You look like you've done a damn good job so far.
Oh, thank you. I appreciate it. Thank you, guys.
How long did it take you to do? How long you've been?
Well, there is a long and short answer on that. First of all, it all started around 20 years ago, shortly after I came to this country. That was around the time C++ Builder 1.0 was released, and at that time I was a C++ developer. I have used some Delphi about a year earlier, because Delphi came about a year or so earlier, around that time, 95, 96-ish. In 96 or so, 96, 97, C++ Builder came out, and I loved it. And I immediately thought that this environment is great, but it can be turned into something like LabVIEW environment. And I started experimenting with the concept. At that time, I was working for Rockwell, and I was doing some low-level embedded development. But as part of that, we were working with huge amount of code, and we are using editors like VI, if anybody remembers what VI is under Unix, to navigate millions of lines of code in hundreds of thousands of files, and that was not manageable to me. I mean, so I started developing development environments for internal usage, so I can use them and I can navigate all that code base much faster. So I started using C++ Builder, developing code parsers, and using those code parsers to parse the code, and then develop code editors and development environments, so we can actually navigate the code, and then other coworkers started using them. So as part of that, I started toying with the idea of components connecting to each other at that point. A couple of years later, after changing a couple of companies, few years later, at ANAS, the same guy who created Memproof and AQ Time and things like that, you probably know him, a Bulgarian guy, quite famous for a while in the development, in the Delphi world. We became friends. Turned out that we are neighbors without even knowing, just a few miles apart. We met and we started chatting. And as part of the discussions, I came up with the idea of not connecting components together, but actually connecting properties together. So the first idea of OpenWire was born. Literally, I mean, before that, I already had registered the domain name OpenWire because I was thinking connectable components, but I switched to the concept of connectable properties, which arguably is the first time somebody was doing binding historically. So I'm not 100% sure I invented binding, but I may have very well at that point invented the whole concept of binding. Then I created the first flavor of OpenWire, allowing properties to bind to each other. Initial version was in C++. In C++ Builder, I developed components for a company I was working at that time with using OpenWire, which I made open source. I converted it very soon to Delphi, so it became Delphi OpenWire. Around that time, I started developing a very basic graphical editor, because before that, you can still connect the components, but you can connect them like this. I'm still sharing the screen, so I will show you. If I go to, let's say, this component, and if I go to the, it should be, let's say, input pin. So I can double click on it and it's going to open the editor, and I can select which input pin I want to connect. You see that, right? I'm in kind of stupid editor, and that's not very useful. So around that time, I started working on some very basic plugin for Delphi, which eventually became this OpenWire editor, and it took many years.
I'm impressed with how you can wire the wires around each other and stuff.
Oh, thank you. Thank you. Yeah,
it's such a beautiful, well done diagramming thing, you know.
Thank you. Again, I'm explaining.
Even Visio doesn't have that good of a wiring diagram in it. Microsoft Visio.
Thank you. Thank you. No, again, as you can see, this has taken literally decades to evolve to the point what you're seeing right now. I can show you screenshots of how ugly and horrible this thing looked 15 years ago. But around 15 years ago, I, for first time, developed a standalone IDE that was using OpenWire graphical development. And I'll briefly show you that IDE as well. It may go through some hiccups.
Does any of your boards have any FPGA on them?
I have boards that have FPGA, and I am toying. It's interesting that you brought it, because I'm toying with the idea of using OpenWire to program the FPGA as well.
Okay.
But that is for another day. So this is OpenWire Studio. This is what I developed as a very primitive environment long time ago to play with the idea of standalone graphical development environment for Windows. So you can use my components and create effectively little applications that you can run in Windows. You can see that it's running at the moment. You see that?
Yeah.
I can even run it in debug mode. And if I run it in debug mode, I can see the data as it is flowing between the different components, and I can even see what the component is. Okay, well, I have some glitch here, but nonetheless, let's say the face offset, I can change the offset a little bit, and I can change it a little too much.
I'll tell you, I think every Delphi developer that cuts his teeth on Delphi makes their own property editor.
That's probably true.
And Delphi would never surface the property editor as a component in Delphi, so everybody's had to rebuild their own property editor in the GUI.
Yeah, I know. So the point is that I developed this IDE, and 5 years ago, so this obviously up to that point was 15 years of development. 5 years ago, when I told you the story about Arduino and how I got frustrated with it, I said, well, I will just take this editor and I will see if I can adapt it instead of running Delphi components. I will see if I can adapt it to actually generate C++ code. And within 3 days, I created the first Visuino. So the first version of Visuino was created in 3 days.
Wow.
That's the short answer.
And then
So
10 years
answer,
of debugging.
Yeah, long answer, 15 years of preparational work. Short answer, 3 days.
3 days.
And then 5 years of evolution after that. So anyway, I mean that's the journey of Visuino until today.
A code writer that makes tools to write his code.
Yeah, kind of like that. Yeah.
That's great.
Yeah, pretty nice. Very lot of work, and
Thank you. Yeah, I'm a bit of a crazy guy, and yeah, again, I mean, we just scratched the surface. I showed you just bits and pieces of the overall code thing. It's
I don't
it's
think you're
much more
crazy. I think you're
interesting.
ahead of the curve.
That's been my idea. I mean, I planned all of this around 20 years ago. So it's good that I had succeeded to plan 20 years ahead of the curve, right? And so 20 years later, I'm still ahead, right? That's not that bad, I hope. Any other questions or anything else you guys want to see? We can do some other quickie or something.
What's the most powerful board that you have in your arsenal that you can support? The fastest board.
Well, I'm really not sure. Well, that's actually the answer would be twofold. Technically speaking, that would be Raspberry Pi, because I recently added support for Raspberry Pi. That's not technically fully correct answer, because my Raspberry Pi support is for now very limited. I'm still experimenting with that, but it is somewhere here. So yeah, right here is the Raspberry Pi. So from the point of view of promise, Raspberry Pi is probably the most powerful, because it's technically speaking a full-blown computer. Excluding Raspberry Pi with its partial support for now, which is kind of in experimental stages, ESP32 is arguably by far the most powerful board. It is fast. It has a fair amount of memory, a fair amount of capabilities. Obviously, it has Bluetooth. You can technically make it work both in Bluetooth and Bluetooth LE and Bluetooth Classic, even simultaneously, though it's a little bit of a complex task. And it has Wi-Fi built in, and it even supports secure sockets on the client side, at least. So I would definitely say ESP32. And to top it off, ESP32 usually costs just a few dollars. So you can get ESP32 based boards for as low as like $3–4. Wow. So it's difficult to beat it in general. And now switch to camera view.
Is that ARM32?
Pardon me?
Is that ARM32, the ESP32, is that ARM base?
I believe it's ARM-based processor, but I cannot swear, because again, I generate generic C++ code, and then it converts it. And then there are toys like this one. This is a full-blown controller. It has ESP32 inside. It has sensors like accelerometer, gyroscope, sensor. Oops. It has a small display and a couple of buttons. It has this one has battery inside, so it has also even battery management unit, which has a monitor. It has some other goodies. Let me see. I have it mapped here. It's Stick C. Yeah, it's called Stick C, this particular one. Actually, it's easier for me to look in Visuino what it has inside, because in Visuino I have map of, oh yeah, it has real-time clock. So it has built-in real-time clock, battery management, yeah, and the display. Oh, it has infrared transmitter as well.
Oh, wow.
So yeah, it's quite a loaded module, costs like $20 or something. But it's pretty useful little controller. And it has a little color OLED. I mean, this is actually a color screen right here. So it's among my popular toys, and it has a groove interface, and it supports hats. So, oh yeah, it has microphone also. I forgot that it has a microphone built-in. So if you want to add speaker, as example, you can get a speaker hat for it, and you just plug it like this, and now we have speaker. And then if you want some sensor, as example, here I am plugging a motion sensor. So now I have a motion sensor and a speaker on this guy, and it has battery. I can just charge it, put it somewhere. It even has a magnet, oddly enough, so I can stick it on something. And it's going to stick. I have motion sensor. Then I can program it to notify me over Bluetooth or Wi-Fi, and hook it to the cloud, or just directly with Delphi or remote XY, monitor it. And plenty of options, actually. Yeah, it's a lot of fun. I have to admit. Yeah.
A lot of fun when you can program and touch things in the real world.
Yeah, I mean, Visuino, one of the things I honestly, personally loved about that, because I designed it for myself, I can program all of that in a matter of minutes, sometimes seconds, versus spending days to code it all properly, right? I mean, trust me, things that normally would take me days, I can do them in less than a minute.
And who can remember the last time they wrote a program in 233 bytes?
And Delphi's involved.
Yeah, that's a challenge. Yeah, that's a challenge.
Okay.
Well, we've reached our 9 o'clock. I want to thank you, Boyan. That was very interesting. Very, very interesting. Thanks everyone for showing up. And I'm going to try to post the replay of this too.
Let's hope that it works.
Yeah, thank you very much. It was very good.
Thank you. Thank you, guys. Thank you. And thank you for showing everybody.
Yes, thank you.
Hey, thanks.
Thank you, Jim. I highly appreciate your hard work.
Well, thanks for coming. It was good.
Yeah.
All right. Bye, guys.
Bye.
Bye. Goodbye, everyone.
Good night.
Night.